Yes.
Yeah.
Cool. Okay, so today we're going to try to do some actual programming, and then I also need to go over the assignment due a week from now. Let's see. So the first thing we're going to look at is numbers and expressions, basically how to do calculations. So for the first program, we basically need to be able to do three things: get input from a user, um, do calculations with those inputs, and then display output. So let's do this. Go ahead and open up Python like we did last time, and I'll show you how to do that real quick. So if you go and search for Python, we have idle, and then we have Python. So what we want to do is, for now, we're gonna use the console or the shell, and let me set this up so that you can actually see what I'm doing. And so let's do this. Let's type in 2 plus 2 and hit enter, and you should get 4. So at this prompt, we can actually just do calculations. If we want, you could put, you know, a large number plus another large number, and it will add them together. So you kind of have the best calculator in the world at this point. And then, you know, it can even, so addition is done with the plus sign. Subtraction is done with the minus sign. Now, multiplication and division is a little different. We want to multiply two numbers, use the asterisk. We don't have we don't use an X because that can be used as a variable name. So we use the asterisk for multiplication, and then we use the forward slash as division. So those are our four fundamental symbols, or our four fundamental operators for doing arithmetic. The other thing that we can do is we have two different types of math we can do. We can do integer math, or we can do floating point math. Everything we've done so far has been floating point math. And for example, if I were to do, let's see, 7 divided by 3, you get 2.3333335. Why does it give me that 5 at the end? Well, what's going on here is that with floating point math, there are some divisions that, you know, if you divide by 3, it's really 3 repeating. And you can't store an infinite amount of precision in a computer because the amount of precision you can store is based on how much memory you're using. We haven't made a computer with infinite amount of memory yet. One day they probably will. But for now, when we store floating point numbers, they limit it in memory. And so at a certain point, if you have a repeating number like this, it kind of truncates it at the end. So that's floating point math. Now, there's another type of math called integer math. And if I do 7 with 2 slashes, I get 2. And basically what integer math does is it basically says, you know, I'm not interested in the floating point. I'm just going to keep the whole number part of the equation. So if I do, you know, 5 divided by 4, I get 1.5. I do 5 integer division 4, I get 1. That can be useful sometimes when we want to kind of do things in whole number increments. We might use the double divide. Does that make sense? So let's see. Now there's another operator called the modulus. So if I divide 5 divided by 4, normally it would be 1 with 1 remainder, right? If I did, let's see, 7 divided by 4, the floating point would be that. If I did 7 integer division by 4, I would get 1. What if I wanted the remainder? Well, I can do 7 modulus 4. And what modulus says, I'm not interested in the what the dividend of that is. What I'm interested in is what the remainder would be after I do division. So 4 goes into 7 how many times? 1 time, right? And what's the remainder after that? 3. Perfect. So if I do that, you can see 7 modulus 4 gives me the remainder. So now we have floating point division, we have integer division, and then we have remainder. And that remainder part can actually be very useful for us. Sometimes if we're looping through something with an index number, we might want to know when every third element is, when every fifth element is, or something like that. We can do that modulus operation. And if, for example, we're at 1 divided or 1 modulus, let's say that we wanted to do something different at every third one. Well, if we did, at the first one, we have a remainder, so we don't do anything. Then we go 2 mod 3, and we have remainder, so we don't do anything. And then we do 3 mod 3, and we get 0. So now we know, oh, okay, we're on the third one. Then we do 4 mod 3, 5 mod 3, and 6 mod 3. And you can see that, every third one, it goes to 0. And so we could check to see, hey, if the modulus of that, by the number of times that we want, at the, every third one is 0, we know we're on the third one. So, so that's kind of, so that's a useful operator whenever we're kind of looping through things and we want to change something we're doing at particular intervals. Make sense?
Yeah, I understand it.
So go ahead and try those and see what you get, and see the differences. You might also try the integer divisions of those. So 10 double/3, 9 double/3. And then look at the last one and try to predict if that gives you the remainder. What happens when you do that with when you get the modulus of 2 floating point numbers, so 2.75 and 0.5. Try to predict what the result is going to be and then type that one in and see what happens. So if you think about it, what are we doing with the integers, and how would that same process apply to floating point numbers? So, and the way you can think about it is this: normally when we do the modulus, we divide the second number into the first one. We disregard the result of that, but we take the remainder. So how many times does 0.5 go into 2.75? 5 times, right? And what's 5 times 0.5? Let's see, can I get... So 0, we're going to try. I have to see if my ability to write with a mouse is any good. Let's see. Hello. So this times 5 is 2.5. And then if I say, okay, I want the remainder, I say 2.7 minus 2.5 is 0.25. So this is the modulus of 2.75 and 0.5. Does that make sense? And in a sense, what you've done here is really this modulus operation is an algorithm, right? It's basically, hey, take the number, divide it, ignore the result, and take the remainder. Well, I can apply that same process to floating point numbers as regular numbers. And if you run 2.75 mod 0.5, you should get 0.25. Did that work for everybody? So, okay, so now we have, you know, the main arithmetic operators there. Addition, subtraction, multiplication with an asterisk, division. Floating point division is 1/, integer division is 2 slashes, and modulus is a percent sign. So now the next thing is exponentiation. How do we raise something to a power? So try this. Put 2 double asterisks 3, and you should get 8. So that double asterisk is how we do exponentiation, how you raise something to a power. I kind of like this about Python. Other languages you have to write power, open parentheses, and a bunch of stuff. This is a nice, elegant way of designating raising something to a power. By the way, one thing with languages you have to understand is that there's a human being who wrote these. And so the decision on, how things kind of work is because someone had to make a decision on how to write the nomenclature of it. And so sometimes that can help you kind of predict what a particular command is. If you don't know it, you can just kind of say, well, if I was going to create this, how would I do it? And a lot of times they come up with the same answer. So in this case, though, it's 2 double asterisks 3. That's raising something to a power. And so try the following: -3 double asterisk 2, and then -3 in parentheses double asterisk 2. And tell me what the difference is. So it's -3 double asterisk 2. What? Yeah. So it's interesting, right? That they both should be, and this is one of the examples where math in programming is kind of like math, and then is kind of not like math, because of the way we write things in, and because of the limitations of the computer. It it kind of makes odd things happen sometimes. So when you put -3 double asterisk 2, What has higher precedence, exponentiation or subtraction? Exponentiation, right? So the computer is very literal and it says, you know what, I need to raise three to the second power first, and then it applies the minus sign. So if we want to raise -3 to the second power with Python, we have to put the -3 in parentheses to say, hey, force this to be a negative number first and then raise it to a second power. So that's just, um, that's kind of, that's an idiosyncrasy of the way that Python works. So that's kind of the same as saying, -1 times 3 squared. So if you place your negative numbers in parentheses, that will force a negative number to be evaluated. We're going to find it doesn't happen that often because more often than not, we're going to store our numbers in variables, and we're going to use variables instead of actual hard-coded numbers to do our math. And so since the variable holds the whole value, that doesn't often become a problem, but it's something to be aware of because, it could be an issue. So we have the basic fundamentals of arithmetic now. The next thing is storing information. And so we're going to use something called variables. And what variable is really a way of storing a number in memory. And a variable is really a name that represents or refers to some value. So try this. Say x equals 3. Put that in the computer, and then enter on the next line, enter x. And it returns the value stored in it. So what we've done here, this is not exactly like a variable in math. What's really happening here is that 3 is being assigned into the variable x. And what the compiler is really doing is saying, hey, I need to make a place in memory. The programmer wants to call it x. So it creates that space in memory. And then when you say equals 3, what it does is it takes the value 3 and stores it in the random access memory in your computer. By the way, when you turn off your computer or when the program stops, it's going to lose that memory. So later on, we're going to learn how to make files and databases to store things, between the time when the program runs. But while the program is running, this variable x is holding the value 3. So rather than saying equals here, what I'm going to recommend you say is whenever you see a single equal symbol like that, say is assigned to. Is assigned the value. So x is assigned the value 3 is probably a better way of saying that than x equals 3. There's some slight differences in how this gets interpreted, and it just as a new programmer, it's a lot easier to say x is assigned the value 3, and it'll just kind of make more sense. And then when you when you just put x there, it displays what was stored in there. So now say x times 2, and you should get 6. And after you do that, enter x again. Now, what do you think will be returned? 6 or 3? Go ahead and type into the chat whether you think it's going to be 6 or 3. And it's just really, there's no right answer here at this point for you because, you're just learning the language. And it really is up to the human being who built this language what would happen at this point. And the way they set it up is they said, hey, if you multiply, a variable times a number, the resulting value would be 6, but it does not change the value that's stored there because notice there's no equal sign involved in x times 2. We didn't assign the results of that back into x. I'll play around with this a little bit more. So hold on a second. I'm going to So we said x equals 3. And then, we had x, and we said x times 2, 6. Now, how could we, let's say we wanted to modify x and actually multiply the value of x times 2 and store that back in x. Well, what we could do is we could do this. X is equal to x times 2. Let me do this first. We see that x was not modified, and then we can say x equals x times 2. Try to get my fingers on the home run key. Okay. So when we do that, now we can see that x is modified. What is the difference between this one and this one? The primary difference is that we have another assignment operation here. And so we multiplied x times 2, then we took that and stored it in x. So we said x, so that's why I like that is assigned. Here we're saying x is assigned the value of what it was before times 2. Does that make sense? And then you can also say things like x is equal to x plus 3. And if I look at x now, it's now 9. We can also do things like take another variable and say another variable y is equal to x times 5. We look at y is 45, but in that instance, x still stays the same because we haven't assigned anything to x. The only way you can change a variable is by assigning something into it. So if there isn't an equal sign involved, then you're not really assigning a new value to it. Does that make sense? Cool. So what can we use for our identifiers? You can use letters, digits, underscore characters, and usually we don't use like single letter variables. We usually use like full words or even compound words. So rather than, okay, we're going to make a variable to hold a name, rather than making it n, you would make it name, N-A-M-E. Or better yet, you might do something like first name or last name, things like that. So you typically want your variables to be fairly verbose. So, typical names might be and usually I like this approach where I will make with my variable names, I'll start them off. So there's actually for Python, often we do it, you might do it this way. First name, you might put an underscore between the compound words. That makes it easy to read. You can also do it this way where you capitalize each subsequent word. There's advantages and disadvantages to both. If you stay lowercase with all your variable names and use underscores, that means that you don't accidentally get upper and lowercase mixed up. And the variable names are case sensitive. So first name is different than first name, for example. Those two are different. So if I want to store a string, I have to use, I have to use things like, I have to use either double quotes or single quotes. And then last name. Oh. Now, the reason why I send this EOL while scanning string literal is I was reading across here and it got to the end of the line before it was looking for a beginning single quote. So it needed to be like this. And you can actually add strings together. Of course, if I wanted a space there, I would do first name plus an empty space plus, then I would get that. Make sense? So we can do numbers. We can play with strings. Remember, with strings or text, we need to have single or double quotes around it, because if I did this, what would happen? What would it think this is? Would it think this is a piece of text or variable?
Variable.
Variable. Yeah, exactly. So the double quote says, hey, I'm not looking for the variable. I'm looking for, I'm specifying a collection of characters. So now one thing with the variables, you can't, you can use upper and lowercase letters, you can use underscore characters, you can use digits, but you can't start it with a digit because it starts immediately trying to treat that like a number and it gets confused. So you can't start your variable names with numbers. Okay, so there's this concept of statements and expressions. At the what we've been writing, whenever we write something at the Python command prompt here, and if it evaluates to something, so like if I put 5 plus 7 times 30 raised to the second power, this is an expression, and it returns a, and we can tell that at the command prompt because this expression, whenever the Python command prompt gets an expression, it just evaluates it and immediately and tells you what it is. We're going to see when we do programs, it will not do that. It will just evaluate it and just throw it away basically, unless you put it in a variable. If I say this, now I have an expression and I'm assigning it into result. Notice that the command prompt doesn't display anything. That's because while this is an expression and at the command prompt, it evaluates your expressions and displays what they are. With a statement, it just does a statement and it doesn't show anything. So that's why we had to then type in a variable. Now, when we just type a variable by itself without the equal sign was a statement. This just putting the result is actually an expression. Then it gives us the result. So this is kind of a subtle difference, but it's useful to understand, to kind of understand how the syntax is operating. So x equals 3 is an example of a statement. It's equivalent to saying assign the value 3 to x, and nothing's returned. And so the interactive interpreter, which is what we're using right now, does not evaluate statements. It only evaluates expressions. Statements are just executed in the background, basically. So try this. And let's see, we're going to switch up now. I think we're going to go to, because I see us in the shell right now. So we've been working with the interactive interpreter. Let's now open up idle. So I'm going to close my interactive interpreter, and I'm going to go to idle. And I'm going to type idle in here. And you should see something like that that says idle. Go ahead and open that up. What do you see that is similar from this Python shell to what we were using before? Notice that it's got this 3 greater than symbols as the prompt. So same thing, you know, if I say print, oh, forgot my parentheses. Works the same way. But there's a difference in that we have a file, and you can actually save what you do here. It's not saving as a program. It's just save. It'll save the results. So you know, I'll just put this on the desktop. I'm going to save it as text because it really doesn't save it as a Python program. And if I go to my desktop, I can actually, if I make it TXT, I can open it up and I can see, and I can save whatever work I did. So I'm going to ask, from here on out, we're going to use the Python shell. And if you can, when you know, save those off and then upload those to learning modules. When we go to here, I will have things like this, number and expressions upload area. So from whatever we do from here on out, at the end of the class, just upload them there so that I can see people are following along with the work. I'm not going to grade these things like I would grade an assignment so much. I'm just going to look and see that you were following along. And then also, if you can't attend the class for whatever reason, you can watch the videos, follow along with the work, and upload the stuff there. And then that way I can use that to ensure that I'm required to have something to make sure that we're maintaining interaction that I'm watching as you're going along. So that's how we'll do it for this course, is when you do the exercises in the presentation, you'll just upload what you finished at the end there, and then that way we can record that we're following along. So that's how we'll do the exercise pieces. Make sense? So so we're going to do the rest here with idle, and so let's try it. So, you know, go ahead and type those in again. X equals 3, type x times 2, get the 6, and then display x is 3. And note where it doesn't return anything, which means that's a statement. So x equals 3 is a statement. And then all the other 3 are really expressions, because the interactive interpreter actually returns a result that kind of tells you it's an expression. And so, you know, when you put x in, it evaluates the 3. When you put x times 2, that's an expression that has a value 6. And x is an expression that has the value 3. By the way, if I go too fast at any point, let me know, and then I'll slow down. It's hard for me to actually. So a lot of you have your cameras on. That helps me out a lot because I can see your expressions and things, and then that tells me, you know, I got it or I didn't get it. What's the difference between idle and the interactive interpreter? Mostly, it's just that you have, you know, those additional menu commands: file, edit, shell, debug, options, and window. I like to start with the just the regular console, because that lets you know that, you know, you can actually do Python commands in the shell. You know, sometimes that can be useful if you just need to do a quick command or something. You can use Python from the shell to do that. That helps system administrators and network administrators if they need to do an automated task sometimes. Try this one. Okay, so yeah, we already did print hello world. And so Yes, so statements and expressions, we talked about that. So we have math. Now we said there's three things we needed to get to today for the program that we need to do for the following week. We need to be able to get input from the user, do calculations. We just did calculations, and then we need to display output. And we already know how to do display output. What command do we use to display output? The print command, right? So so the way we get input is actually this way. So say input and life, the universe, and everything. And what you should get is when you type in that input, everything, this input is actually a function. And with the way we know it's a function is we have these parentheses. And what's inside these parentheses, very similar to the print command, is a string. And very similar to the print command, it displays that. But you'll also have this cursor sitting here blinking after you do that. And what it's doing is it's with, unlike print, what input is doing is it's waiting for you to type something in. So go ahead and type the answer to life, the universe, and everything, which is 42. Anyone read Hitchhiker's Guide to the Galaxy? So we put in the answer to life, the universe, and everything, and then you'll notice that it returns, that it then displays 42. So we did this command, and it returned, and then the interactive interpreter displayed something. Is this a statement or an expression? Yeah, it's an expression. Because so the input command, it's just by itself actually evaluates to something, and what it evaluates to is whatever the user types in. So that's not extremely useful by itself, because normally we get something from the user, we need to store it in order to be able to use it. So what do we think we're going to use to store it? We're going to need to use a variable. So this is typically how we actually use the input statement. We have a variable on the left side. We use an assignment operator, and then we say input, and then we put some kind of prompt. This prompt in here, like this is actually not a very good prompt because it's not really telling the user what X is or what units X is in. When you do a prompt, you want to make sure that it gives the user all the information they need so that they can give you good, useful information. If you've noticed, all applications in the world give you excellent instructions on what to input, correct? No, most of them are crap. They give you horrible instructions, and that's why you're irritated and frustrated with most computer applications out in the world. To be one of the arts to being a good programmer is, even with a console application, if you give them good instructions, you're controlling the human being to give the computer good information. So we think we're making programs to be things that humans control. In reality, what we do, if you want your program to work well, your program is actually controlling the human being to give you good information so that you get good data. If you think about it, an application like Amazon, what's it doing? It's giving you it's giving you the options for you to get to the thing you want. Make sure you select what you think you actually want. And when you put in the selection, you pick the right, you don't have to deal with the actual order number of it. You don't have to type that in. You click on the picture and it in the background stores the order number. And then when you put in your credit card number, it does a whole bunch of validation and everything to make sure that that number is in the right format. So a lot of the art in programming is presenting things to the user so that you get the right information in. And that's actually the power of, for example, automating things for business. A lot of the hard part of a business is getting good data that is consistent. And that begins by giving good instructions here. So This would have been better. Please enter the X coordinate in meters or something like that. But we'll go with this because we don't want to type that much while we're learning this stuff. So when you do that, the prompt, just like before, the input statement displays the prompt. Go ahead and type a number in. And then let's do another one. We'll say y equals input y. And we'll get a prompt and we'll type in another number. Notice that in these cases, it did the prompt and got the number, but it didn't evaluate that as expression because these are statements and it stored whatever the user typed into X and Y. And what do we think the answer is going to be? So 4 plus 2 is 6, 4 plus 3 is 4, 5, 6, 7. So probably 76, right? Does that make sense? Instead, we got 3442. Why did we get 3442? Because the numbers are strings. Remember, when there are strings, what happens is it just puts the strings together. So the problem is that if we want to get numbers, we can't really do it that way. So, and I don't have this on my slide, so I'm going to fix it now. So instead, we're going to, if I put the number 34, or if I say input X, notice that there's quotes around this. So the regular input statement always returns a string. What we need to do is convert that into a number. And the way we do that is with the conversion function. And so if I say int, and I pass a string into it for like 34, I will now get the number 34. So int 34 plus int 42 would actually return the results. So the way I really want to write this, if I want to bring in a number, is I would do this. And what I'm doing is I'm doing two things. I'm bringing in an input. It's going to come in as a string. I'm now converting it to an integer, and now I'm putting it into X. Does that make sense? And then I'm going to say y is equal to int input y. And let's see, 42. And then if I say X plus Y, I get the actual math. I can also do this way. X equals float input X. Let me make sure it's the right one. I have a bunch of languages running around in my brain. Sometimes yeah, that's correct. 42 point or some value type 3. And so I can either use int or float to convert a string into a numeric value. Probably most of the time you're going to be using float, because you'd only use int if you really wanted an integral value. If I said X equals int input X, and then I entered like a 5.5, I'll get an error because 5.5 is not an integer. So most of the time, unless you really need to be a floating point number, you're probably going to use float. Make sense? So you have the input statement that brings back a string. And then you have a conversion function, either integer or float, that converts it to a number. And that's how you get a number. Okay, so we already ran idle. I guess I got there a little early, but idle is basically what's called an integrated development environment. It used to be when we were writing programs, we would have a text editor, and then we'd have a compiler, and then we'd have a linker, and then you would run each of these steps one by one. Programmers are lazy, so what we do is we write a program to do anything that's repetitive. And so since that's repetitive, they made integrated development environments that do all those steps for you in the background. And you'll see that that's a continuous theme in programming. If you find yourself doing something repetitive, you can almost guarantee some programmer has something out there to automate that for you. And so we're going to, from here on out, we're going to use idle. And, it looks very much like the same. Notice that you have, unlike the console, you have menu items at the top: file, edit, shell, debug, options. And, we already did print hello world, and it worked just fine. And so, that, that works the same as the console, but we can save what we did by hitting file. So let's do this one again. Do 2 raised to the 3rd power, and you'll get 8. That's the so that works the same. There's also another way we can get to that. There's an equivalent function called the power function. So there's a bunch of these math functions. You can imagine if we try to come up with symbology for every mathematical function: sine, cosine, tangent, radians, conversions, all these other things. After a while, we would be using up the entire keyboard, and it would hurt to memorize that. I actually learned a program in high school, a language called APL. APL stands for a programming language. My instructor actually came up to me and said, "Okay, for your next assignment, you're going to learn a programming language." I said, "Okay, what's it called?" He said, "A programming language." I said, "What's it called?" It's actually APL stands for a programming language. So that was fun. But APL is interesting because they have a special keyboard overlay for it, and every command is a symbol. And it's great if you're a mathematician. It's horrible if you're a normal human being, because you end up you write this whole complex formula, and unless you have all of those memorized, to go back to read it is just really, really difficult. So it was an interesting experiment. Everyone said that's terrible, and then never did that again. And so in programming now, the fundamental math is being done. You do that with these operators, but from then on, all the more complex formulas are done with functions. And so one of them is the power function here, which does the same thing as these double asterisks. I use the double asterisks usually rather than this, but this illustrates how a function works. What makes something a function is there's an identifier, so in this case, pow, and then you have parentheses with 0 or more arguments in here. Well, to raise something to a power, you need to know what you want to raise and what power you want to raise it to. So there's 2 arguments in here. The 2 is what we want to raise, and 3 is what we want to raise the power to. Does that make sense? So it does the same thing. So go ahead and type pow 2, 3, and you'll see it does the same thing. And there's a whole bunch of math functions in Python. And if you go to Google and type Python and the function that you want, you'll find documentation that will show you what the function is. And your book will list a bunch of common functions. So sine, cosine, tangent, absolute value for ABS, floor, ceiling, all those are functions that are available, but you write them out this way. And of course, normally you wouldn't just write them out this way. You would assign the results into a variable or use that in a more complex formula. So you can think of a function like a little program, and we say that you call a function. So in this case, the name of the function is pow, and then we can have 0 or more parameters or arguments inside the parentheses. If there's no arguments, you'll just have open close parentheses. And so try this. We're going to have a complex equation here, say 10 plus the power of 2 raised to the 3 raised to the 5th power divided by 3.0. And go ahead and calculate that in your head and then hit enter. Just kidding. Just enter the formula. If you can do that, let me know. There's people who can use that talent. And you should get this. And so there's a bunch of stuff going in here. We have exponentiation being done with the operator. We have a function being used to do some exponentiation. We have, and actually, one of the things that comes up is what's the order of operations? Well, I have a link here to where this is explained. It's going to be basically the same thing you learned in math. So exponentiation has the highest order of precedence. Well, first of all, parentheses will force the order of precedence. Then exponentiation, and then multiplication, division, and then addition, subtraction. That's the basic order of operations. And that will change the results. So go ahead and try this. Say 3 plus 5 divided by 2.0. And you should get 5.5. Val, it's basically the same thing. Pow is just a way of writing that as a function. You can use the double asterisk in the same way. We're kind of showing that one because that's an example of where operator is doing the same thing as a function, and so they're interchangeable. So what order is this done in? What's the first thing it's done? Is it the 3 plus 5 or the 5 divided by 2.0? Addition or division done first? Yeah, the division's done first. So that gives us our 2.5. We add 3 to that and we get our 3.5. Then try this with putting the parentheses around the 3.5. I mean, 3 plus 5. And then, in your mind, figure out what the result will be and then hit enter. One of the things with programming that's really helpful is as you're going through and you're writing code and you're reading the book, try to predict what the results are before you hit enter. And after a while, that will actually train your mind to think like the computer. And it'll help you with debugging and figuring things out. So we look at that. 3 plus 5 is 4 divided by 2.0. I'm expecting 4. Okay, I got 4. I therefore understand what the math is or what the program is doing. So it's kind of what you can do is you can find expressions, write them at the command interpreter, try to predict what it's going to do, and then see if it does it. And that can help. So exponentiation is the highest precedence, then multiplication, division, and modulus. Those are all in the same category. So those are actually done from left to right. Then all the addition subtractions are next done left to right. And you can always force the order using parentheses. Now here's the trick. Yes, PEMDAS. Now, if you're not, the thing is that the nice thing is you can write something out in the computer program and then you can test it. So you give it your best guess, you throw in some test cases, you look at the results. If the results are off, then you look at your order of operations, you throw parentheses around to fix it, and then usually you get it. So you can approach this by really understanding your operations. you can also approach it from the idea of, well, I'm going to give it my best guess, and then I'm going to test it, and then I'm going to verify the results. You always want to test it no matter what. So, you know, you don't have to necessarily be an expert at that, as long as you verify your results. Now try these. ABS minus 10. What does that function do? And then try 1 divided by 2, and then try round 1.0 divided by 2.0. If you do that, what you'll get is you'll get, you know, absolute is clearly the absolute value function, right? So you can kind of see, hey, you know, you can kind of probably guess what a lot of functions would be if you kind of know what they are, what you're looking for. Now, if you usually you can Google these things, you can go to, you know, you type in Python absolute value, and then you know look up the results, and it'll find you the you know a command. It'll probably tell you about ABS, but we have an absolute value function. 1 divided by 2, of course, gives 0.5. Round 1.0 divided by 2.0. How's that different from the integer division? Yeah, the integer division basically truncates. It just throws away everything after the decimal point. Round will actually, if it's actually, I'm surprised that should have been 1, I think. Let me see if what it does for me. Oh yeah, let's see. And then if I do 2.0 divided by 3.0. Oh. Yeah, that rounded to 1. Let me just put it in. If I put 1.6. Okay, that's rounding. Okay, that makes sense. That's weird. Weird. It's rounding 0.5 down, but 1.5 up. Okay, yeah, I have to figure out why that is. That seems off. Weird. I'm going to look that one up. That's weird. Normally rounds should round 0.5 up. We'll look at that a little later when we look at formatting, L. Yeah, so I'll need to. That's a weird bug. I don't know if it's in the current version of 3.821. Huh. Interesting. Everyone get the same results, 0.5 rounded down. Yeah, that's weird. Okay, so let's take a break. we will reconvene at 10:40, and I'm going to go over the next assignment. We have enough to do that, I think, and then we'll continue on with the rest of the material in this module. Okay, so let's take a look at the next assignment, which will be program 1 pyramid. So if you go to a Blackboard, the assignments generally are at the bottom of each one. I've listed the final project here. That's due at the end of the course. The one that's going to be due a week from now is this one. And basically, so comments. So if we look at so how do we make a program? Well, as opposed to what we've been doing so far, which has just been typing in here, to make a program, we go to File, New File, and you'll notice that it creates a document. Now, the difference between these two is this. Here, you notice that we don't have the prompt. So this one on the left is a program. This is really just typing things in at the command line. And we generally begin our program by putting a comment header. I kind of make it, let's see, where are we? Convenient, you can actually just copy this one and paste it in. And obviously change. I'll ask you to name your programs, your last name, P1, P2, P3, etc., and then put in your name and then your email address. And often we'll also put in a date. So this number sign basically is a comment, and what it tells the compiler to do is ignore this. So we use those to put our own, to put basically messages to other programmers or ourselves in here. And most programs are going to be something like this. We're going to say get input, do calculations, display results. And I will often start my program this way by just laying out in comments what I want to do. So what did we learn? Let's say that we want to make a program that adds two things together. What did we learn so far that would allow us to get two numbers? Let's say I want to get num1 and num2. Yeah, the input statement. So just like we did before, you would look at that format and say, okay, I want a num1. And what would I put next? We could do int. Let's do float because that way we can deal with floating point numbers. And then I have my input statement. And then we put in our prompt. So please enter enter first number. Now at this point, I might actually run this. Now to run your program, you click Run Module, and it's going to ask you to save it. And so I'm just going to put it in the desktop for now. And I'm going to call it addition program.py. And when you save your program, put .py on the end. IDLE will not automatically add that for you, and it makes it a lot easier to open if it says .py. So I'm going to save that, and now it's running the program. It's saying, please enter the first number, put 45. Okay. Well, to get to my second one, I can do the same thing. So I'll just copy that. change this to bring in num2 and change this to second. And you can, by the way, the run has a shortcut key, F5. What I recommend is whenever there's a shortcut key, just, you can't remember it. So the first, half dozen times you're going to go up here, see run module, and then just come back here and then use the shortcut key. And after a while, you'll remember the shortcut key. So F5 will run your program. It's almost like that in almost everyone. So now we've got our inputs. Now we need to do calculations. So someone tell me how I would write I want to get the sum of those two numbers. So how would I do that? Yeah, we could do print num1 plus num2. I'm going to do it this way, though. I'm going to put it in a variable. That would be correct because all we really want is the, is to display the results. But I'm going to break the steps up just to because often what we're going to do is we're going to get inputs. We're going to do we're going to do an intermediate result. And sometimes you may have multiple steps here where you're getting inputs and then doing an intermediate result and getting more inputs and then doing an intermediate result when you're doing something more complex. And then here we're going to say print and with the print statement, we can use commas to separate out what we're printing, and it will do each of these things separated by commas one after the other and put a space between them. So if I do that and run this, then we have a full up program. We're getting input, we're doing a calculation, and then we're displaying the results. So I'm going to put this in here into the chat. So if you had trouble following along, you have that. That's kind of a pretty good, basic structure for a lot of a basic calculation program. Does that kind of make sense? So let's look at what this program is going to do. So this is going to be that only a few more formulas. You're going to write a program to calculate the surface area and volume of a square pyramid. And so if we look at a square pyramid, then the area of one side of a pyramid is basically a triangle. So well, first of all, let's look at volume. Volume is pretty easy. If given A as the length of the base and H as the height of the pyramid, then the volume is just this formula, A squared times H divided by 3. So we learned a bunch of formula stuff today, and you just basically that's actually going to be the easiest thing. The harder part is going to be figuring out the surface area of the 4 triangles. You don't need, in this program, you don't need to calculate the area of the base. If you do, that's fine, but really the requirement is only to do the 4 triangles. Well, to calculate the area of the 4 triangles, one of the things we need is this slant height. And you can see this dotted line that's S is basically going from the top of the pyramid all the way down to the middle of one of these bases. And so we need that slant height because the area of a triangle is 1/2 base times height. But we don't need this height for this triangle because that's not the height of that triangle. It's this slant height, which is the height of that triangle. So to get that slant height, it's this formula. S is equal to the square root of H squared plus A divided by 2 to the square power. Now, square root is a function in Python. You can just use sqrt, open parentheses, and pass a number into it, and that will figure out the square root. So you're going to use the square root function and then calculate h squared, which is the height of the pyramid, plus a divided by 2, which is the base of the squared, added together, and then take the square root of that, and that will give you the slant height. Once you have the slant height, then the area of one side is at the slant height times a, which is the base, divided by 2, which is just the formula of a area of a triangle. And then obviously to get the area of all four of those, you have to multiply that by 4. So what this program you're going to do is tell the user what the volume of the pyramid is and what the area of all four sides of the pyramid is. And so basically your inputs, which you're going to get with the input statements, are the length and the height. Once you have that, you'll do these calculations and then you'll print out the results. Now, the way I would attack this program is I would do it in pieces. Writing the whole thing could be kind of complex. What I would do is first I would get the length and the height of the pyramid, get those inputs, get that functioning. I pretty much kind of given that to you. You know, that's these two pieces right here, right? Only you wouldn't rather call it num1 and num2. I'd probably call it base and height. Once you have that, maybe just figure out the volume. The volume is the easier one. Do the calculation for volume and display the volume. Now you've got that piece. You can figure out the volume. Once you have that volume, then I'd figure out, add in a formula for the slant height, and just actually, you know, it doesn't say to report the slant height, but you might as well just display the slant height, verify that that's working. And then finally, I would figure out the area of one side and multiply it by 4 and say, okay, the area of the four sides is this. Do you see how I'm breaking the program down into individual small? I'm making 3 small problems rather than one big problem. If you find yourself trying to write these things, you know, if you find yourself not hitting run or F5 pretty much every 3 lines or so that you're writing code, you're going to find that it takes much, much longer, because if you try to write the whole thing out and then run it, you know, again, if I have 30 lines of code and I have and it doesn't work, where's my problem? Somewhere in 30 lines of code. But if I write 5 lines of code and run, then my problem is in those 5 lines of code. So do it piece at a time. Get the input, test it. Do the calculation for the volume and print it, test it. Do the volume calculation for the slant height and print it and test it. Then do the final piece and test it. Does that make sense? Yeah, if you want to use Visual Studio Code, just don't. Basically, though, when you upload it to me, I just want the PY file, because I don't want to have to pull it out of a Visual Studio Code project. So are there any questions on the program that's going to be due? And I think I may have. Let me make sure I did the due dates right. Let's see. Actually, I need to ship these all down one day. This is actually, let me fix that right away. I wanted you to have a whole week to work on it. That doesn't look like a whole week. Because I want you to have the chance to ask me a question in class. So this needs to be there, yeah. So I just explained P1, that means it's due a week from now. Save that. Okay, so you have till next Wednesday on this one. So that gives you the weekend plus another class period. Okay, any questions on the assignment? All right, so I'm going to go back to the presentation and finish out today with the rest of this presentation. So there's actually other functions in math in the math library. Some of the functions aren't available just in the core Python program. So we have to use an import statement to import math. So try this, import math, and then say math.floor 32.9. And what you'll notice is that the math.floor will lower the number down to 32.0. And so the math library is a library that has even more functions. But to access them, once you import a library, you have to specify in Python the library you're using with. And so we do that by saying math dot. And then that gives us access to additional functions which are in the math library. The reason they do that is because there could be multiple math libraries out there, and they may have different floor functions on there. And so by making you say math dot, it makes sure that you're telling Python which library you want that function from. And so the dot operator really is by saying, give me the floor function that belongs to this thing on the left. So it's getting something that is part of something else. And you can try this too, even though we've used the floor function, notice that this is still a floating point number. If we wanted it to be an integer, we could use the math conversion function of int, and that would convert it to an integer. And then note there's also a ceiling function. Ceiling will round up, floor will round down. So we have round, which rounds on 0.5, unless it's 0.5, which is weird. And then we have the floor function, and then we have the ceiling function. So different ways of rounding. Now, another one is the square root function. And there's another way you can import. So rather than just saying import math, you can also import this way. You can say from the math library, import just one function. So this is actually importing the square root function from the math library. And you'll need to use this for this program because you need square root. And so if we do it this way, notice that we don't have to say math dot. Because we're importing this one function, then we can just reference a function directly, and we don't need math dot square root. In fact, math dot square root won't work if you import something in this way. And so you could actually just have a series of lines from math import square root, from math import, a ceiling, from math import, and then you could just use those without having to say math dot. The other way you can do it is you can just separate it by comma. So you say import square root, comma, ceiling, comma, floor, and you can import just the functions you need from the math library. And so this is probably, I kind of like this approach. It makes the code look a little cleaner. I don't have these math dots everywhere, but either one approach will work fine. Does that make sense? You can even rename functions. So you could say import math and say foo equals math dot square root. And then if you say, give me the foo of 4, it'll give you 2.0. That's only used on occasion when, let's say you have two different math libraries you're working from, and they both have a square root function, but you have one that you prefer. You could rename one of them, and that way they wouldn't conflict. This is driven by the fact that Python is an open source program. And so there's no, like Microsoft sitting there and telling all its employees how they're going to name things. So because open source libraries can conflict with each other, we need to have some ways of aliasing or renaming things. You don't have to do that very often. I'm not going to get into complex math. If you're interested in that from a math perspective, let me know. That's a little bit too much for this point. So algorithms. So I already went kind of through this. I went over the program on how to write a program. A program is basically an algorithm. So at the interpreter, which we've done so far, we've just been doing individual commands. When we wrote that one program, that addition program, that was actually a full up program where we say file new, we went file, new file, and then we got this file that doesn't have the prompts here. This is actually a text file. One way you can tell if you're in the shell or not is one, the shell has prompts, a file doesn't. The other thing too is notice that the program has the ability to run. You don't have a run over here on the shell. So you actually in idle have a shell and then you have your actual programs. And when you save these, again, just a reminder, don't forget to save with .py, and then you can save your program wherever you want. To open it up again, you can open up idle and say file.open, and then you can go find your program and open it. But an algorithm is like a recipe. It's an ordered list of steps. And so really a computer program is an algorithm. It's a series of steps. And so you can actually make your program. You don't have to use idle to make your program. You can actually write it in Notepad or Notepad++. Someone mentioned using Visual Studio Code. Idle is not necessarily the best editor, but if you're first starting, I recommend using it. It's because it doesn't have a lot of stuff around on it. Some of those other editors use a lot of configuration you have to do. So we're going to use idle. And, to start a program, you click new file in the shell, the idle shell, and it brings up an empty editor window. And notice that there's no Python prompt there. And so you can start, you start typing, you save the file, you pick a directory and always put .py on the extension. And then to run the program, you go to the program itself and there's that run module where you can hit run F5, and then it runs your code. So we've kind of done all that. What I'd ask you to do is in your shell, hit File, Save As, and save it as a text file. And then in your program, make sure you save your program and just go to learning modules. We're still in chapter 1. And down here we have numbers, expressions, upload area. So I'll go ahead and do it since. Would I save it? I put it in the desktop. Yeah. So I saved mine as classwork.txt, and then you can just go to here, browse my computer. So I have my classwork, then I'll browse my computer again. And so just go there and put in whatever you did. And if you want to, you can put comments if you want, but really I just need that. And then when you submit, it'll upload that, and then I'll give you credit for doing the classwork. Now, if you, for some reason, miss a class and you have to go back look at the recording, I'm going to put the recordings like here. I already have recorded from previous class here, but I'll put the recordings where the PowerPoint is. You'll see later ones don't have them yet, but as we record, I'll put the recording there, and then you can follow along with the recording, do the work, and then just upload it to the upload area, and then that way you can get credit for doing the work, even if you can't be in class. I highly recommend though, if you're new, if you haven't done any programming before, you attend the class. That way you can ask me questions. And then as a reminder, if you have any questions, you can when we're not in class, you can go to Teams and post the questions there. That way, if anyone else has the same question, it'll already be there. They can look there and they might get their answer right away. It helps us all out if we're kind of all in the same space asking questions. Now, if there's a question which is not, you don't want everyone to see, use email for that. Make sense? Pretty cool. So we got to the point where we can make a little calculate program. That's pretty cool. That's already useful for a lot of things. And next week we're going to get into using sequences and collections, so we can do things with bigger groups of numbers. So thank you very much. That's all I have for today.